Guys, welcome back to my channel. This is problem set 5 of the lecture series Signals and Systems. In this video, we will be seeing about partial fraction expansion and we'll be solving some questions later on. So let's get started. So in the previous video, we saw about analysis and characterization of LTI systems using Laplace transform, and specifically we saw two properties, which is nothing but the stability and the causality. So stability, we said we need to include the j omega axis. The ROC should include the j omega axis. And for causality, the ROC should be the right half S-plane. Right? So one important point I forgot to state it in the previous lecture is when the system is both stable and causal. Stable and causal. So what happens? Your ROC should include the j omega axis and also should be a right half S-plane. Which means your ROC will look something like this, right? But this is directly also related to the poles. So what does it say for the poles? It says all the poles should be on the left half S-plane. So this is a very important property, and you can also see this later on when you study control systems. Okay. So for a causal system to be stable, all the poles should be in the left half S-plane. So this is what I wanted to convey today. And now let us move on to the partial fraction expansion. So this is very useful in finding the inverse Laplace transform of rational Laplace transform, which what we'll be using in most of the places. Okay. So we'll be using rational Laplace transforms, and it will be of the form, let's say am s per m plus am minus 1 s per m minus 1 and so on, divided by bn s power n, because numerator and denominator can have different powers and degrees. So bn minus 1 s power n minus 1 and so on up to b0. Right? So now I can also rewrite it in the form of poles and zeros. So I'll have a constant term and then I'll be having zeros. So s plus z1 and so on unto s plus zm divided by s plus p1 and so on up to s plus pm, because you will be having m zeros and n poles depending on the degree. Okay. So in this case, my z1s, zi's and pi's can be complex, right? Because we have given only single poles. So before moving on, I'll just give some of the revise some of the Laplace transform pairs which will be useful. Okay. So the first one will be e power minus at u of t. Of course, u of t, you know, it is nothing but 1 by s. And I'll be only writing it down for the ROC such that real of s is greater than real of minus a. Okay, only for these cases. So here it will be 1 by s plus a. And then you have t power n minus 1 by n minus 1 factorial e power minus at u of t. This will give me 1 by s plus a to the power n. And we also have the cos and sine, right? Cos omega naught t u of t will give me s by s square plus omega naught square. And my sine omega naught t u of t will give me omega naught by s square plus omega naught square. And we also have the e power minus 8t cos omega naught t u of t. Here you also notice that a is 0. So this will be adjusted accordingly. You will have real of s greater than 0. Okay. So here you will just have s replaced with s plus a. Okay, because it is like a frequency shifting. And you have e power minus 8t sin omega naught t u of t, which is nothing but omega naught by s plus a whole square plus omega naught square. So now if you see this and compare them with this one, you can see when you write it down in the partial fractions, you will have denominator of the form s plus p1, s plus p2, and if the poles are repeating, then you will have square, cubes, and so on. So for that you can use this inverse Laplace transform, and for single pole you can use this one, and for complex, these are all for real a's, right? And if you have complex, here it is s equal to plus minus j omega naught, right? You can use cos and sine. And if you have complex plus real, so here the pole is nothing but minus a plus minus j omega naught. So you have this form, you can use this form of the inverse Laplace transform. So once you find the partial fraction, you can use these Laplace transform pairs to find the inverse Laplace transform. So it is also important for you to first itself, when you are converting into the partial fraction, to convert it in these forms. Okay, so that is what we will be seeing now. So let us go to the first case. Case 1. Each pole occurs only once. So no repetition in the poles, right? Basically, if I have to take an example, so let me give s plus 1 by s plus 2 into s plus 3. Here you can see there is no repetition of the poles. So I have to write it in the partial fraction like this. A by s plus 2 plus b by s plus 3. So how will I go about finding a and b? One way to do it is cross multiply, and you collect all the s terms, right, and all the constant terms, and you compare left hand side and right hand side. And then you will get two linear equations, one for the coefficient of s, another for the constant term, and then you can solve. So that is one method. So method 1 is cross multiply, compare LHS and RHS, and solve linear equation. But this is very hectic, I feel. So we will see a simpler method. So for that, let us see what happens when I multiply each of these separately with h of s. So what happens? I get s plus 1. My s plus 2 goes away. I'll just have s plus 3. And this side I'll get a plus b into s plus 2 by s plus 3. So now what I do, I want to find a. So I have to eliminate b. For that I'll substitute s equal to minus 2. So s plus 2 into h of s. In this equation, I substitute s equal to minus 2. So then, minus 2 plus 1 by minus 2 plus 3 is equal to a plus 0. This term goes to 0, right? So now I can easily get a. A is nothing but minus 1 by plus 1. So it is minus 1. Similarly, if I want to find b, what I do? I multiply with s plus 3. So s plus 3 into h of it. S at s equal to minus 3. So I can substitute here minus 3 plus 1 by minus 3 plus. So it will be s plus 2, right? So this will be nothing but s plus 1 by s plus 2, because s plus 3 is going away now. At s equal to minus 3, this is equal to, you will only have b terms because a term will go away. You will have a into s plus 3 by s plus 2 plus b at s equal to minus 3. So here you will have minus 3 plus 1 by minus 3 plus 2 is equal to b. So b is nothing but minus 2 by minus 1. So b is 2. So then your h of s is nothing but from here minus 1 by s plus 2 plus 2 by s plus 3. So you can just verify by cross multiplying and checking once. So minus s minus 3 plus 2s plus 4, right? So you will have one s term and you will have plus 1. So it is correct. So this way, for single pole, if you have only one of the s term or the constant term in the numerator, there is even much simpler way. So h of s is equal to, let's say, any number I can take, 4 by s plus 2 into s plus 10. Okay. Now I want it in the form of s plus 2 by s plus 10. So if you see in my previous video, I have solved it very faster. So I'll just explain how I am solving it that way. So now I want only the constant term here. I want to eliminate the s term when I cross multiply. So I'll just take 1 and minus 1 so that s minus s I'll get and the s term is eliminated. So now when I do like this, what term will I end up with? So I'll get 10 minus 2. So I'll end up with 8. But I want 4 here. So what I do? I just multiply with half. Okay. So then my coefficient will be half by s plus 2. And it is minus 1 into half. So it will be minus half by s plus 10. So it will be half of 1 by s plus 2 minus 1 by s plus 10. So this is how I solved it very easily without going through this derivation also, like this multiplication and then seeing what happens to h of s. So you can directly get this. So to cross check, you can just multiply and see. S term will anyway disappear and 10 minus 2 will get 8 and you have half outside, so it will become 4. Similarly, if you have only the s term here, so same example I'll take, s plus 2 into s plus 10. So now you have only s term. What you have to do now? So first let us write down the denominators. So now you want to cancel the constant terms. So how will you do that? So 20 is the LCM. So you can either multiply 10 and 2 directly. So here it will be 2 and here it will be 10 and you have to subtract it. So it is minus 10. So if you see 20 minus 20 will go away. And what happens to s? You will have 2s minus 10s equal to minus 8s. So now you have to multiply by minus half to get 4. So just multiply by minus half. So what will be my partial fraction? 2 by s plus 2 minus 10 by s plus 10. So if you have to simplify, it will just be minus 1 by s plus 2 plus 5 by s plus 10. So you can cross multiply. You will get minus s minus 10 plus 5s plus 10. So this will go away and you will get 4s. So this is how you quickly solve it. And even for this case, you can do that way. It's just a little bit complicated. And you have to go through some trial and error method, right? So it is good for this method for if the numerator contains like both the s and constant term, you can go with this method. Otherwise, you can just simplify your method this way. But you also need practice to gain speed in this method as well. You should not make any mistakes. Okay, moving on. Now we'll see for repeated poles. So again, I'll take an example. Let's consider s plus 1 by s plus 2 into s plus 3 whole square. So in my partial fraction, it will be like a by s plus 1 plus bs plus c by, this is s plus 2, s plus 3 whole square. I can do it this way, or I can just split this and write b by s plus 3 plus c by s plus 3 whole square, right? Of course, bc is not same as bc I wrote before because there will be a plus 3 term. We can also represent in this way for some b and c, okay? So now I want to find a, b and c. So for a, it is easy. Just you have to do s plus 2 into h of s, s equal to minus 2 will give me a. This is easy. But if you see for b, s plus 3 into h of s, what will this give me? This will give me a into s plus 3 by s plus 2. As expected, a will become 0 when we substitute s equal to minus 3. And b we'll get as it is. But c, if you see, it is still having the denominator term. If you substitute s equal to minus 3, it is going to go to infinity. So we don't want that, right? So first we'll see how to find c. C is easy. You just multiply s plus 3 whole square h of s. Now b will also have s plus 3 term, and you can just substitute s equal to minus 3. This is straightforward to find c. Now let us see how to find it for b. So for b also, you first take this s plus 3 whole square into h of s. So observe what will you get. You have a into s plus 3 whole square by s plus 2, right? Plus b into s plus 3 plus c. Now I want to eliminate this c, and the c is a constant. So what I do, I just take a derivative. So d by ds of s plus 3 whole square h of s. So then what will I have? This you can see, it will be 2 into s plus 3 by s plus 2 minus s plus 3 whole square by s plus 2 whole square, right? You can see that as long as this power term is greater than the number of derivative we take, that s plus 3 will still remain. And when we substitute s equal to minus 3, this will still go to 0. But my b will have this just the b, and my c will go to 0. Now if I take s tends to s equal to minus 3, I will arrive at the value of b. So this is how you do for repeated poles. Okay, this is for power 2. If it is like power n, right? If you have something like 1 by s plus a power n, then I can write it as some, I'll say b1 by s plus a plus b2 by s plus a square plus b3 by s plus a cube, and so on until bn by s plus a power n. So for my bn, it is simpler. You just multiply s power a power n into h of s and take s equal to minus a. So what I'll do for bn minus 1, you just multiply same n, but you take derivative h of s. So now what will I get? I'll just get a single constant term. So s equal to minus a. So now when I do it for bn minus 2, I need to take a double derivative, right? S equal to minus a. But you should also be careful with the constant terms when you're taking derivatives. So you should see for bn minus 2, what you will get is, so when you multiply this with s plus a power n h of s, you will have b1 s plus a power n minus 1 and so on, plus b n minus 2 into s plus a square plus b n minus 1 into s plus a plus bn, right? For the first derivative, this will go away and this will be a constant term, and this will have a term of 2 and this will have a term of 1, right? Maybe I'll represent in different color. First derivative, this will get 2, this will get 1, and the second derivative, this will be s plus a, so 2 into 1, and this will go away, 1 into 0. So I'll get 2 into 1 as the factor here. I'll not just get bn minus 2. So I'll have a 2 here, 2 into 1, which is nothing but 2 factorial. So I have to divide it by 2 factorial, right? Similarly, for b any m, what I should do? I should divide it by n minus m factorial and d power m by ds m s plus a whole power n h of s at s equal to minus a. So this constant term I need to be careful. Okay. Otherwise, this is also straightforward. So now, until now, we have seen all the real poles, right? So if you have imaginary, then you will have you will end up with e power jt, right? Minus jt or jat, something like this. And this we have to finally convert into cos or sine term. But for doing that, we'll just directly find it in the form of 1 by s square plus omega naught square, or 1 by s plus a square plus omega naught square. If you find it in this form, then it will be easier for us, right? So we'll look at that in case 3. Having complex poles. So let us take a simple example. So I have 1 by, or I'll say 2s I'll take, okay? S square plus s plus 1. So if you see, my b square minus 4ac for this is 1 minus 4 is minus 3 is less than 0. Quadratic equation, right? So the zeros of this denominator, which is nothing but poles for us, is going to be complex, let's say complex roots, right? So in that case, how do we solve? So we want our basic ideas to bring it to this form. So let's see how to do it. So if you have any expression here like a, you first divide by a and bring it to this expression such that the s square term is having a coefficient of 1. Okay. So here it is already having coefficient of 1. So we needn't bother. So I have s square term. Now this s, I have to write it in this form. If I expand this, what will I get? S square plus 2as plus a square. So now I have to find this a, right? So my a will be nothing but here half. So I'll write it like this. 2 into 1 by 2 into s. And I add and subtract by 1 by 2 whole square. Okay. So if this is negative, then I'll have a negative sign here and I'll have s minus a here. That way. Okay. Simpler only. So then I have this term plus 1 here already. So now let me combine. So this is nothing but s plus half whole square. And I have minus 1 by 4 plus 1. This when I combine, I'll get 3 by 4. So 2s by s plus 1 by 2 whole square plus 3 by 4. Now if you see, my denominator is of this form, right? So this I can rewrite it as 2s by s plus 1 by 2 whole square plus root 3 by 4 whole square. So my denominator I brought it to this form. But numerator also I need to take care. See, for cos it is numerator is nothing but s plus a by s square plus omega naught square. This is s plus a whole square. And for my sine it is just a constant omega naught. So this coefficient I needn't bother because I can always multiply by some term and multiply here, right? But I need to bring it to this form s plus a and some constant term here. How do I do that? So here it is s plus half. So first I will take this constant term outside and I will just subtract, add and subtract minus half. Okay. So now then what I will do? I'll just split this. So I'll have s plus half by s plus half whole square plus root 3 by 4 whole square and minus half by s plus half whole square plus root 3 by 4 whole square. So this I brought into cos form, right? And this one I need to take care. So I can rewrite this as minus half into root 3 by 4, which is nothing but root 3 by 2, right? Or I'll write it this way. Root 3 by 2. I multiply and divide by root 3 by 2. So I need to divide 1 by root 3 by 2. And then I just write it out, the denominator as it is. Root of 3 by 4 whole square. Okay. So now I can just cancel the terms, and this whole as I can write s plus half by s plus half whole square plus root 3 by 2 whole square minus 1 by root 3 by 2 by s plus half whole square plus root 3 by 2 whole square. So this is as my cos term, and this is like my sine term, and easily I can take the inverse Laplace transform. So extending this in case 4, even if you have the mixture of these both, right? Let's say mixture of real and complex poles. You should still be able to solve it with the knowledge I have given already. So let me take an example. So 1 by s plus 1 into s square plus s plus 1. So you need something like a by s plus 1 plus b by s square. Sorry, this will be bs plus c, right? Plus s plus 1. So finding my a is straightforward, right? I just have to multiply by s plus 1, h of s, and s equal to minus 1. So after finding a, b and c, how do you find? For b and c, you just cross multiply. Same. You cross multiply and compare LHS and RHS, and then solve the linear equation. Okay, so this will be easier for you. And usually they will not complicate it by asking with so many poles. So this will again be straightforward. Okay, so that's all I wanted to cover regarding this partial fraction expansion. So now let us look at some questions. So coming to the first question, given that e power minus a to u of t gives a Laplace transform 1 by s plus a, and your real of s is greater than real of minus a, determine the inverse Laplace transform of this function. So this is easy for us, right? So first we'll take x of s. So denominator first we need to factorize. So factorizing also is easy. Here you can see your product should be 12 and your sum should be plus 7. So this will be nothing but plus 3 and plus 4. So we just write s plus 3, s plus 4. So this will be 2 into s plus 2 by s plus 3 into s plus 4. So you can again cross check if you are in doubt. If you see, you will get s square plus 3s plus 4s plus 12. So you will get the same denominator back again. Okay. So from here, we have to do the partial fraction, right? So I write a by s plus 3 plus b by s plus 4. My a is nothing but s plus 3 into x of s at s equal to minus 3. So this will cancel. So 2 into minus 3 plus 2 by minus 3 plus 4. So 2 into minus 1 by 1. So it is minus 2. And b is nothing but s plus 4 into x of s at s equal to minus 4, which gives us 2 into minus 4 plus 2 by minus 4 plus 3. So this is 2 into minus 2 by minus 1, which gives us 4. So my x of s is nothing but minus 2 by s plus 3 plus 4 by s plus 4. So quickly we can cross check also. Plus 4s plus 12. So this will give me 2s plus 4, which is nothing but 2 into s plus 2. So it is right. So once we have found this, we have to just use this inverse Laplace transform they have given. So here we have real of s greater than minus 3, right? So what will be my inverse Laplace transform? My x of t is nothing but minus 2 e power minus 3t u of t plus 4 e power minus 4t u of t. So that's all, simple. Let us move on to the next question. Suppose we are given the following facts about the signal x of t. Okay, we have x of t equal to 0 for t less than 0. So this means it is cos I. And my x of k by 80 is equal to 0 for k equal to 1, 2, 3. So it is something like cosine or sine form, right? Because they only go to 0 at recurrence of 2 pi. And we also have x of 1 by 160 equal to e power minus 120. So it also has some e power minus 80 form, something like that. Okay, right? Let x of s denote the Laplace transform of x of t and determine which of the following statements is consistent with the given information about x of t. Okay, let's see the statements. X of s has only one pole in the finite s-plane. Okay, x of s has only two poles in the finite s-plane, and x of s has more than two poles in the finite s-plane. Okay, so this is again very easy question. So we already found out the information. So I'll just write it down. So one says x of t is causal, right? Which also implies a multiplication by u of t. So then the second part, x of k by 80 equal to 0 for k equal to 1, 2, 3 and so on. Let's say some sine omega naught t, let's take. And if I substitute t with k by 80, sine omega naught k by 80. So then my omega naught k by 80 equal to n pi, right? It should be equal to 0. This x of t itself should be equal to 0. So my omega naught is nothing but n pi by k into 80. And n and k are, let's say, incrementing normally. So my omega naught will be some integer multiple of pi by 80, right? So what can you observe from here is I have some sine of m pi by 80t term as product. This are either cos or sine, anything can be, okay? So this implies that x of s, the Laplace transform should have two complex poles, correct? Okay, so my first option is already eliminated. Then they also given in the third, my x of 1 by 160 is equal to e power minus 120. So what it means, if I have something like e power minus 80, at 160 I will have e power minus a by 160. This is equal to e power minus 120. So my a will be nothing but, this is 120 only. So my a will be 120 into 160, right? Some pole. But this also corresponds to another additional pole apart from this. One additional pole. So my x of t has at least 3 poles, right? So my second option is also wrong. So my x of s is having more than 2 poles. This is the right option. So this is how you solve the question from the given information. You go step by step and try to determine what that given statement says about x of t or x of s. Okay. So let's move on to the third question. Again, this is again based on statements. Suppose the following facts are given about the signal x of t with Laplace transform x of s. So first it is given that x of t is real and even. So we need to use the properties of real and even. And the second, it is given x of s has 4 poles and no zeros in the finite s-plane. Okay. And third, x of s is a pole at s equal to half e power j pi by 4. So one pole is given. And fourth, your minus infinity to infinity, x of t dt is given as 4. So what does the first information say about us? Okay, x of t is real. So what it means? So let me say, take my Laplace transform. X of t e power minus st dt. So if I just substitute it with x star of t, so if I want to take the star outside, I just do this x of t e power minus s star t dt. So this is equal to x of s star. So my x of s is equal to x star of s star. So now my x of t is even. So this conveys two informations. It means x of t is two-sided. So we get the information about the ROC. So now it also conveys some information which we'll derive. Since we need not remember these, right? So we can easily derive. It will just take 1 minute. So x of t e power minus st dt. But x of t is equal to x of minus t for me. And now if I just substitute t with minus t, I'll get the limits anyway will be crossed over because of dt be going to minus t. So they'll come back to the same thing. X of t e power st dt. So it means that my x of s is equal to x of minus s, right? So we have these two informations. So now let us look at what is given. So x of s has 4 poles and no zeros in the finite S-plane. So second one is x of s has 4 poles. So it will be something of this form. S plus a into s plus b into s plus c into s plus d. So now let us use these both conditions. So one of the pole, like if a pole s is present, a is present, then minus a also should be present. Due to condition 2. So I can rewrite this as a by s plus a, s plus b, s minus a, s minus b. So what does condition 1 say? Okay, let's just find it out. It may not be trivial for you. So a by s plus a into s plus b into s minus a into s minus b is equal to, a is constant, so we'll just take it as a. Let's not give it a star. It's a real number. So I'll have s star plus a star, right? First let me do this. Or okay. On top of this, I'm going to take a star again. So again, s star plus b star, s star minus a star into s star minus b star whole star. So then what will happen? A by s plus. So here we are just replacing s with s star. So this will not be there. So I'll get s plus a star into s plus b star into s minus a star into s minus b star. So what it says is, if a is a pole, then a star is also a pole. So now I can easily get all my poles. So I have a by s plus a into s plus a star and s minus a into s minus a star. Now you can see, using those two conditions, I have got this simple form. Now I have, if I know one pole, I can find all the other poles, right? And that is what our third condition is. S equal to half e power j pi by 4. Equal to half e power j pi by 4. So my x of s is nothing but, and this is nothing but half into cos pi by 4 plus j sin pi by 4. And this is nothing but 1 by 2 plus j 1 by 2. So 1 by 4 plus j by 4. So a by s plus 1 by 4 plus j by 4 into s plus 1 by 4 minus j by 4 into s minus 1 by 4 minus j by 4 into s minus 1 by 4 plus j by 4. So these both we can combine. What I'll get? I'll get a by s plus 1 by 4 whole square plus 1 by 4 whole square into s minus 1 by 4 whole square plus 1 by 4 whole square. And what else I need? So this one they have given as fourth condition, but this is nothing but x of 0, right? If you see in this expression, if you substitute s equal to 0, you will just exactly get LHS. So your x of 0, fourth condition, is equal to 4, which is nothing but a. Your a by 1 by 4 whole square into, this is 1 by 4 whole square plus 1 by 4 whole square into minus 1 by 4 whole square plus 1 by 4 whole square is equal to 4. So a by, this is 1 by 16 plus 1 by 16, which is nothing but 2 by 16, 1 by 8 into 1 by 8 equal to 4. A into 64 is equal to 4. So a is equal to 1 by 16, right? So what I'm done, okay, so this cos pi by 4 is actually 1 by root 2, right? So this will be 2 root 2 and 2 root 2, okay? So everything else will change. So 2 root 2, 2 root 2. And this will be 2 root 2 and 2 root 2. Okay. And your 2 root 2 is nothing but 8. 2 root 2 square is 8. So I'll just write. We will have 1 by 8 plus 1 by 8 into 1 by 8 plus 1 by 8. So which is nothing but 1 by 4 into 1 by 4. You will have 16 here. And this will just be 1 by 4. So your x of s is nothing but 1 by 4 divided by s plus 1 by 2 root 2 whole square plus 1 by 2 root 2 whole square into s minus 1 by 2 root 2 whole square plus 1 by 2 root 2 whole square. Okay. So what they have asked us, x of s and its ROC. So x of s we have found and its ROC we have to find. So we saw that it's a two-sided signal. And where are these poles located? It is at 1 by 2 root 2 plus minus 1 by 2 root 2 plus minus 1 by 2 root 2 j by 2 root 2. So where are these? 1 by 2 root 2, 1 by 2 root 2, and these are somewhere here. So what will be my ROC? This region, because it is a two-sided signal, right? So your ROC is real of s less than 1 by 2 root 2 and greater than minus 1 by 2 root 2. So this is our answer. Okay. Now let us solve some of the GATE previous year questions. So the first question, if f of s is equal to Laplace transform of f of t is given by 2 into s plus 1 by s square plus 4s plus 7, then the initial and final values of f of t respectively are. So for this, we need to know the initial and final value theorem. So my initial value theorem, x of 0 is nothing but limit s tends to infinity s x of s, and my final value theorem is, just swap 0 and infinity. Limit s tends to 0, s x of s. Okay. So this you should also write it in the general form of limit t tends to infinity. But I'm just okay with it, right? And here also it is 0 plus. And you also need the conditions for x to be a causal one, right? But then the question they haven't mentioned, because when they're asking initial and final value, it means that f of t is causal. So let us find f of 0 first. So it is s into x of s, which is x into 2 into s plus 1 by s square plus 4s plus 7. And I have to 10 limit s tends to infinity. So infinity, only the highest power terms will survive, which is nothing but 2s square by s square. So which is nothing but 2. My initial value is 2. So from this only you can find option B is only right. Still we'll just find the final value. S into 2 into s plus 1 by s square plus 4s plus 7. So if you substitute 0, what do you get? 0 into 2 into 1 by 0 plus 0 plus 7, which is nothing but 0. So 2 comma 0 is your answer. Moving on, the unilateral Laplace transform of f of t is 1 by s square plus 1. The unilateral Laplace transform of t f of t. So for this again, you need to know the properties of Laplace transform. So f of t is given as 1 by s square plus s plus 1. So I need to find t f of t. Suppose let's say in the examination hall I do not remember this formula. What do I do? So nothing. Just go to the Laplace transform equation. X of t e power minus st dt. So now I need to get tx of t here. What do? I just take derivative with respect to s. X of t, I'll get minus t s my e power minus st dt. But I just want tx of t, so I just take minus sign this side, which will give me tx of t e power minus st dt. So this, for f of s, I just need to take the derivative. So minus f of s df of s by ds is nothing but minus d by ds of 1 by s square plus s plus 1. So minus into this derivative will be 1 by s square plus s plus 1 whole square. Will have a minus sign into 2s plus 1. So minus minus will cancel. So I'll have 2s plus 1 by s square plus s plus 1 whole square. So which is nothing but option D. Okay. Very simple. So you needn't remember all these formulas. You just need to remember the derivation. That way you can do it very easily. Okay. You can free up your mind and understand more concepts. Okay. Moving on to question 3. Let the Laplace transform of a function f of t, which exists for t greater than 0, be f1 of s, and the Laplace transform of its delayed version f of t minus tau be f2 of s. So f of t, L is f1 of s, f of t minus tau. This is nothing but f2 of s, but we know this is nothing but e power minus s tau f1 of s. Correct. So let's read further. Let f1 of s conjugate be the complex conjugate of f of f1 of s with the Laplace variable set s equal to sigma plus g omega. If g of s is equal to f2 of s, f1 star of s by f1 of s modulus square, then the inverse Laplace transform of g of s is an ideal impulse, delayed impulse step function or delayed step function. So this is again a very easy question. So what do we have here? f2 of s nothing but e power minus s tau f1 of s into f1 star of s by f1 of s whole square. So now this product is nothing but f1 of s whole square. So this will get cancelled. I'll just remain with e power minus s tau. So inverse Laplace transform of e power s minus s tau g of t is nothing but delta of t minus tau, right? So what it is going to be? It is going to be delayed impulse delta of t minus tau. Okay. So that's it for today. I hope you all learned something new and which will be helpful along your preparation journey. Keep practicing, keep working hard, and soon enough you will start to see the results. Take care. Bye bye.